And it's recording. So here we go. 5.3. So what do you need to know in this exercise, or what are you taking out of it? When you know what types of data or where it goes, or what types of data you have, well, then how do you get data to begin with? So data usually comes through surveys, questionnaires. Those are the ones that you're probably most familiar with your projects during high school from year 7 to 10. So you got questionnaires, you got surveys. You can do it through observations, like me sort of observing you. That's how I collect my data as well. As I'm communicating with you, I ask you questions, I collect data, and I just put a record somewhere. So I do that for my year 8s as well. Digital footprints, so your emails, if you sent me something and I can see your thinking, that's how I can collect data. Search engines, that's how they collect data on Google. Your searches on Instagram and Facebook, etc. That's how they get data. You could do measurements, simple experiments or census. Anyone know what a census is? What is the census? Parents usually do it once every while. Census, for those who don't know, it's pretty much the data for everyone in their household in Australia will then complete a document, and it'll say how many people in your household, how many siblings do you have, name them, how old are they, what do they do for work, how much do they earn, and it gives a general data for the entire population of Australia in that particular year. They don't do it every year. They do it every few years just so that they have a general idea of how Australia's population is growing, what's the average income, etc. That's how they gather data, but that's a big task to do. That's why they don't do it every year. Okay, so that's census. I'm highlighting it because it is a key thing to understand for the next bit. Next one. So we know that collecting data, there's many ways to do it. But when you write your questions to collect data, there are actually two usual types. Sometimes you can do a bit of merge of the two. But the two key distinctions is closed versus open questions. Okay, and there's obviously benefit for closed questions, and there's also benefits for open questions. What are some of the problems can you think of an open question? So an open question is something like, what's your favorite food? That's an open question. Very good. So whilst it is more accurate to exactly what you are or what you like, so let's say you said you like Taco Bells, but most people say Macca's or whatever else it is, there are answers that I may not expect. So the data can be harder to measure exactly what I'm looking for to answer the question that I'm interested in. Whereas closed questions, it's nice that if I just said, do you, out of the options, Macca's, KFC, Hungry Jack's, and Domino's, which one do you like? See that, the problem with that is whilst I will get a good data, you might choose Domino's or you might choose Macca's. The problem is that data, maybe you only chose that because those are the only options you got. But truly, you like Taco Bells. But you couldn't put that in, so you chose Taco Bells. Yeah, so the problem with closed questions, whilst it's nice for analysis, greater for analysis, it's harder to be accurate. So that's what I wrote here. Greater for analysis, so if you want to do data collection, that's better. Not as great for accuracy. Okay, so you have to kind of balance between the two when you create your own survey and questionnaires. Then it leads to this key part, which is what I wanted to really highlight. In methods and specialists, and maybe in general, they use the word, or in psychology as well, so those who do psychology will know this one. Population versus sample. At foundation, you just need to understand that population means everyone. Okay, so in your notes, maybe just write on the side, population equals everyone. Versus sample is part of target audience. So what's an example? If I wanted to know if ViewBank students, literally ViewBank students, like chocolate, then that means I will have to survey every single student in ViewBank because I said ViewBank students. Then I'll have to do a population. But if my question was I'm just interested in, year 12s at ViewBank, then the year 12s at ViewBank, I can select all year 12s or I can select a class of year 12s. So it depends on how accurate I want to be here or how much data I can get. Sample is a representation of the population. Why do you need to know the distinction between the two? Because that determines whether you do a survey or whether you do a census. See, a census is population, everyone in Australia. Sample, it's much easier to do. It's more cost effective. That's why if you ever... Actually, you guys might not have seen it yet, actually. You're too young. Actually, I'll ask anyway. Have you guys ever seen, if you walked by with your parents in a bar or maybe somewhere at a local, like Greensboro Plaza, somewhere on a board, there's like those slips and it has like the number and it says like voluntary participation or participation call this number. Have you guys ever seen that? Hands up. Or can be? Can be. But those slips, sometimes on those notice boards, on a community board, some people are doing research, and that's what I did when I did a psychology major in my Bachelor of Science in Teaching. You can do a research, and in order to get participants, the more participants you get, the better your data is. But the problem is that I can't get everyone. It's too costly. Like if I ask you all now to do a survey, what's the motivation? Unless I told you, if you do the survey, I'll give you $1 million. I'm sure everyone will do it. But I don't have $1 million for everyone. So how do I get people, especially when I was at Melbourne Uni, how do I get students to sign up to participate in my experiment? So sometimes I work with the university cafes. So they give me a little voucher. So those who sign up, I can give them a voucher. I say, hey, you get a free coffee if you join to do this experiment. But I have those little notes on a notice board and they walk by, they see the experiment, they see what I'm looking for, and they might rip off a tag and it has my sort of details. They contact me and then they participate in the experiment. That is me getting a sample of people from Melbourne University. But, what if I don't want people from Melbourne University? What if I want people from Melbourne? So then how do I get people from, say, Baldwin to Box Hill to Doncaster? How do I get them to know? So that's where it's difficult. The smaller the sample, the easier it is, the more cost effective, but less accurate. The more people you can get, the better it is, but it's more costly. That's why the census only happens in a few years, because it's very costly to run. Someone has to process them through all the data. Okay? So that's a general understanding. As if the question ever comes up as to why do you choose population versus sample, you have to think, is it for everyone or is it just for a group of people? What's your purpose of your question? Yeah? All right, that's pretty much all you needed to know out of that. So here, what do you feel in here? Census is conducted by an entire population. So just remember, population refers to everyone. Whereas surveys, data is collected from a sample of a given population. That's the idea. So sample, because you don't need everyone. You just need to know a bit of a general idea. Population, if you, for whatever reason, really want to know everyone's opinion or data. Okay? So for example, Google would probably want as much data of the population as they can. The more they get, that's how they get the money from. Yeah? Because they have data population is what they have, not sample. All right, let's see the next one. So in this exercise 5.3, what are you required to do? You are required to figure out, well, do I use a bar chart, pie chart, histogram, etc.? But at the moment, you're just deciding what's the benefits of using a bar chart and a pie chart. So you need to know how to draw it properly. One of the things you guys mentioned in the last session that you already knew, bar charts must have what? Gaps. Very good. So bar charts must have gaps. What else? So bars must be separate. What else is there? So have a look at that bar chart there. So when you're drawing your own, there are a couple of details the examiners will look for if you're doing this for next year. What are they also looking for? So looking at all of them, the way it's designed. Very good. So they have to be to scale. So that's one of the things you got to use a ruler when you're sketching these. I've already made axes for you scaled, but if you do it yourself, you actually have to draw out the scale. So it has to be evenly scaled. True. So it must be evenly scaled. What else? The title. Very good. So these two, the title on the very top, which is what is the graph representing. You need both the X and Y axis titles. Without the titles, you will get penalized as well. There's one more detail, very specific, that makes it different to histogram as well. The arrow, you can actually get by without the arrow, so this is okay. Arrow's not 100% needed. Yes, definitely categorical data for bar graphs. But there's one more little detail that they will penalize you on if it's not clear. I'm going to zoom in just to see. Yes. So this here, notice the bar, it's always in the middle, in between. So notice basketball is in the middle. AFL is in the middle. Yeah, whereas histogram's not. See, histogram's the other way. Histogram is going from one end to the next end. So it goes like 20 to 30 to 40 to 50 to 60, but that's numerical data. With categorical data, because you got to keep it separate, we already knew it had to have gaps, but you can't just draw them to the end of this. You don't write AFL here, you actually write it in the center. So that means the bars, they all have to be centered. Okay, so usually if you do it on Excel, it does it for you already, but when you do it by hand, in the exam, when they give you a bit of a bar chart, you have to then fill it in yourself. You make sure it's in the middle. Okay, so write that as an extra note. Make sure items or data in middle. So it needs to be in the middle. That's the bar chart details. Otherwise, yes, what I really liked is that you notice it had to be categorical data. That's one of the first things bar charts are used for, categorical data. You can use numerical, but if it's continuous numerical, it wouldn't work. It has to be discrete for that to work. Okay? Versus pie charts. We said the pie chart is for categorical. Great. So they're both categorical. Good. But when do you use pie chart versus bar chart? I mean, you won't be wrong if you did it with a bar chart, but there is a general purpose of when to use a pie chart. So think about the times you've seen them. Yes. Very good. Now, percentages is actually a percentage of a whole. Okay, so if I wanted to know the population of Australia as a whole, then I want to know how many is, earning 100K and above. How many is earning between 80 to 100? How many is earning between 70 and below? But that's out of all the people in Australia. So it has to be anything to do with a whole. Okay, so when you get a whole, then that's when you do this. So shares, for example, in a company. See, in a company, let's say Nike, you want to know how much do the people on the board, committee board, how much do each person hold overall? What's the percentage overall? Yes, it's as a whole. Or if you think about profits and loss, how much of it is loss? How much of it is a profit? And how much of it is sort of like a standstill? Or if it's in a school, how many full-timers are there versus part-timers, and how many casuals are there, and how many are there ES, as an example, because I'm looking at the whole school. So anything that's a whole, pie chart is great. What's the problem with pie charts? Whilst it's great that it's a whole, if you have too many elements in it, so if I was looking at races in a school, if we had too many, like 48 different ethnicities, then that's just too hard to read the percentage graph, and it's actually better to read it in a bar chart. So one of the problems is that whilst this is great for a whole, if you have too many components that you're looking at, it makes the graph harder to visualize. Yeah? All right, so those are the two that you need to just pick out. So I try to explain it in a way that's more logical, that you don't have to memorize, but more so just understand and go, oh yeah, that's what I would have done, and that's why I would have chosen that. Okay? All right, so today's example is really just practicing making sure you draw a bar chart correctly. And then if you were to draw a pie chart, do you know how to find out the percentages? And once you know the percentages, do you know how to draw it so it's actually 2% and 20% and say 77%? How would you do it? If I gave you an actual diagram, how would you perfectly draw 77%? Or you're going to eyeball it. Okay, so here we go. Flip over to the next page once you're ready with all these notes here. So today's lesson is just getting you to draw bar charts and pie graphs. Okay, over here, I've just put in some tips there, but those are the things I already mentioned from last session. What are common mistakes that students in Year 12 do in the exam? They use a histogram, not a bar chart, for categorical data. They forget to label. That's what Ishara picked up before. Treating categories, postcodes, that was last lesson. Most students think postcodes are numerical, but it's actually categorical data. Not checking totals. So when they're doing a pie chart, they're not checking if the percentages actually add up to one whole, which is 100%. Okay? So often, really, they're just testing, do you know how to choose a graph? And do you know how to explain why it's suitable? Yeah? Let's do this example together. So the table below shows the results of a survey. So you've got someone doing a survey. They're probably asked, what is your favorite sport? Okay, so what's your favorite sport? And they've chosen closed questions here. So they gave a list of AFL, basketball, cricket, netball, rugby union, soccer, tennis, and those are the only options you have. So it's closed questions. From those closed questions, I have 6 people who like AFL, 2 for basketball, 7 for cricket, 2 for netball, 3 for rugby league, 1 for rugby union, 2 for soccer, and 1 for tennis. So the question is, how many people did I survey? And how would you calculate that?
First, look at we see that 6 is 25%, so that must mean that in total it's 24 for the frequency, which is 24.
Oh.
Then we know that 6 is at least 25, so then we can kind of work off that and see.
That's so creative. Do you guys know what Liam just said there? Hands up if you understood what he just said. Sorry? He said 24, but do you know what he was doing? He didn't add all the frequencies, actually. He didn't add them all up. That was the way I thought you guys would have done, but he actually came out with a different way. Anyone understood what he just said? He said 6 is 25%, and then he had 24. What did he do? Why did he times it by 4? It's a quarter. Because 6 is 25%. You need 4 of those to make 100%, which is a whole. So he said, well, 6 times 4 is 24. So it's much easier than adding all of these together. Does that make sense? That's pretty cool, actually. Well, let's see if it works. 6 plus 2 is 8. 8 plus 7 is... Actually, oh no, can we assume that, actually? Let's see if it works out, actually. 8 plus 7 is 15. 15 plus 2, 17. 17 plus 3 is 20. 20 plus 1, 21. 23, and 24. That was pretty cool. I like that, Liam. That was nice. Creative thinking. All right, so here we go. So we know it's a total out of 24. Now going back to percentages. How do we get 25%? Well, we knew we've got 6 people that like AFL. Out of how many people in total? There were 24 people in total. But 6 out of 24 on a calculator. So if I gave you a calculator, how do you convert that to a percentage? How do we do it? Millie? Times by 100. Very good. So we need to times this by 100. Now on your calculator, if you don't know how to do this bit, that's okay. There should be a fraction button. You can type 6 over 24 and then times by 100, or 6 divide 24 times by 100. But that times 100 is the first thing. You want to convert anything into a percentage, you need to take the fraction times 100 or a decimal times 100, and it will change it to a percentage. Okay? So I got 6 out of 24 times by 100, I get 25%. If you want to do basketball, it's the same thing. It should be on your calculator. You type in 2 out of 24. So 2 out of 24 people. Times that by 100. And you should also get your answer. So here we go. I'm doing a calculator so you can see. So remember, I'm not trying to teach you the theory. I'm trying to teach you how to use your calculator so you can problem solve, yeah? So here we go. Calculator. So if you can't do a fraction like my one can't do it, then it's 2 divided by 24 because it's 2 out of 24. And then you times it by 100. So I get 8.33333%. So I'm going to write there, that's 8.33 with a dot on the top to say it goes on forever. So 8.33%. Let's do the next one. Cricket is 7 out of 24. So here we go on my calculator. Do it again. 7 divided by 24. That gives me the fraction, gives me the decimal, times by 100. And I get 29.1666. So here, 29.16, and it repeats itself, so 29.16%. Netball, we already know it's 2 again, so it must be 8.3%. What about 3? 3 is the same thing. 3 out of 24 technically is 1/8, but again, you can follow with your calculator. So here we go on a calculator, you can do 3 divided by 24 times 100, and you get 12.5%. Can I get a show of hands who know how to use Excel? Okay, let me quickly show you. I'm choosing Excel because most companies out there, when you go out and work, people don't do this by hand. They actually use Excel or some program. Excel is one of the most easiest ones to start off with. So I'm just going to write it in. So the numbers were 6, 2, 7, what was it? 2, 3, 1, 2. And 1. So in the real world, you probably use things like, you only need to know a few things. Like if you want to add them all together, one of the words in mathematics is called sum. So if you type in the equals button, type sum, and you just select the cells you want. So you want all of this to be added together. So SUM is sum. There we go, we've got 24. If you want the percentage, so let's say I label this and call it the percentage column. See this one? You just type in, if once you know a bit of mathematics, you can actually show your mathematical thinking here and it does the calculation for you. So here, you told me it's 6 as the number of people that like AFL, 6 out of the total, so you do 6, this cell, B2, divided by B10, so let's divide, and then Millie said times that by 100. That should give you a percentage. So I'll do that. I'll literally write in, I need B2, I need it to divide with 24, so divide is a /, so just divide. I need to divide this number times by 100, 25%. See what I just did there? So I'm just going to write here, so you can see B2, I'm saying take this number, divided by that, times by 100. Same thing with this one, I'm just going to need this number, divided by that, times 100, and it should give it to me. But here's the problem. I want that number to always be the same. It should always be 24. So you can either change B10 to 24, or you can actually fix it. And I can actually write here instead, equals, or let me fix that. You put a $sign in front of B and a $sign in front of 10. By putting a $sign in means fix this column. And then putting a $sign on 10 means fix this row. So it means it always uses the cell. So if I do that, I still get my 25, but what's cool is you click on the cell and on the corner you can drag it down. And look at that. No one does this by hand anymore. That's just me trying to teach you a bit of theory, but in reality, when you get out there, you do an office work. Those ladies at the office, I'm pretty sure they're all over this. My wife, for example, does this all day. She's got like triple screen, and she's dealing data, and it goes from one cell to the next cell. That's the kind of work you do out there. So it's still add, subtract, multiply, divide. You got to learn how to do it quicker. You're not going to sit there with a calculator and just do all this. So here's your answers if you want to fill it in. So you're at 8.3, 29.16, 8.3, 12.5, and then we had 4.16, 8.3, and 4.16 there. But at the end, if you add them all together, if I sum all of this together, I should expect to get 100. And that makes sense, because that's 100% of everyone. That's 24 total. These are your percentages. Cool. So you do need to know a bit of Excel. You're not going to use that in the exam, but you will do that for your SAC. Okay, so for your SAC, I will be assessing, can you utilize the maths that I'm teaching you to create a graph, to analyze a graph, to interpret a graph? That's what at the year 11 level in your SACs, that's what I'll be doing. Okay, so you do need to know how to figure out to find out these numbers. You don't have to use Excel per se. Use whatever it is that you can use, but you will need to demonstrate to me there's tools out there that you can solve effectively. Okay? All right, there we go. So we're filling it all out. Let's go. That was 12.5, 4.16%. What was this one? 2 again was 8.3. And then 1 was 4.16%. Great. So now that we know how to do the percentages, we've got a table. Fantastic. Here's your graph. This is called a frequency table or a bar chart. So we've got a frequency table here. We're going to convert this data into a visual aspect. So your employers usually don't care about this. This doesn't make sense to them. They just want to see overall. So here we're going to put it all out so it's easy to see. So here we go. If I did it on Excel, you literally just take this and then you go insert. Actually, I should have done AFL. I should have labeled it over here. I'll do that next time. Don't worry. We've got an exercise where I actually teach you how to do a bar chart. But if you want to, you just needed to label that as AFL, basketball, etc. And then you've got the percentage, and it can then do a chart for you. But you go to insert, and on the side over here has all these bar charts that you can choose, like that, and they'll be able to do it for you. Okay? But I'll teach you that in the next one of the exercises as we get there. Yeah.
Just really quickly, on how would I convert the thing into a pie chart?
On a calculator?
Yeah.
I don't think you can sketch a pie chart on a calculator.
No, because it has 2,000 as the total, but it's in 100, so 340.
Which one are you doing?
The one down there,
This one?
yeah.
And you're saying On your count. Oh, I see. So you're trying to say how to get. What are you trying to say now?
I'm trying to figure out how would I come in with a calculator to get percentage?
Ah, got you.
Same as before, or just
Exactly same as before. So it'll be for this one will be 50 out of 2,000. So 50 out of 2,000 total times by 100 on your calculator. So 50 divided by 2,000 times 100 will give you your beautiful. Yes, you're right. That is a quarter. So it should be 25%. Very good. All right. So here we go. The bar chart. I've got a couple arrows that I wanted to remind you. When you sketch these bars, so AFL, we have a frequency axis here. So this must be frequency. But you should label it as number of people. Number of people. So for AFL, how many people chose for their favorite sport? It is 6, I think it was. 6 for AFL. Remember, you don't do it like this. It's not like that. It's a bar chart, so there should be a gap between them, and AFL should be in the center. Oh, whoops. It's harder to do it on screen here, but it should be in the center. Make sure it's in the center. Same with basketball. Basketball was how many people? It was 2. So we expect 2. When you're doing this, if it's in an exam for next year, make sure to have a ruler. I'm obviously using the function on OneNote where it does make it straight. But you do have to use a ruler. It needs to be centered. Cricket, we've got 7. Here we go, 7. Centered. Netball was 2. So again, we've got 2. Rugby league was 1. Rugby union was 2. Soccer was 2. And then finally, tennis was 1. Okay, so we've got frequency labeled. This is number of people. On the top, you must say it is favorite sport. Or some version of that. So we know that this survey, what is this about? It is to see people's favorite sports. Okay, so people's favorite sports. People's favorite sports. And then remember, this needs to be centered. Okay, so here I've got sport, here I've got number of people, and I know the graph is about people's favorite sports. So on a quick glance, without looking at the chart, I can already say cricket must be one of the most popular. We can already see these two are equal, so rugby league and tennis on a quick glance. You can see, I mean, you can see it in the table, but it's a lot more convoluted, isn't it? And imagine if I had like thousands of data, you don't want to be sitting there looking at a table. The graph is much better. Okay, that's why we use visual graphs. So that's the first one. So learning how to do a bar chart. And now let's flip over to what Ishara was doing. So here we go. We're going to do example 2, and that's it for today. And you already learned how to find some percentages. So here we go.
So I think the onion's wrong.
Onion.
Oh, I'm sorry. No, the one that you did for me because it's 50, but it's higher than the 300. And I put it all of the percentages.
Oh, you're right.
And it's 121. So we're 20 over.
Yes, that 15%. Is that right, actually? Wait, 50 divided by 2,000 times by 100. Oh, it's 2.5. Sorry, not 25%. 2.5. That's 2.5% for onion. 300 was 300 divided by 2,000. And then you times by 100. Yep, 15% is correct. Next one, 750. So 750. Actually, I'm going to use Excel because it's just quicker to do. Let's do, here we go, Excel. This is this one. So how many do we have? We've got 300, 50, 7, 50, 30, 8, 70. And then I can delete all of these. Yeah, that works out. There's your percentages. See the beauty of Excel? I just literally type in. I had the formulas already set. I just need to type in the numbers. So I had 300 for dry beans, 50. Actually, that number's not right. What's going on? Did I put 750? 750, whoops, 750. Ah, there we go. Woo! Now that makes more sense. Haha. So, you can see 300, 15%, 50 is 2.5%, 750 is 37.5%, 30 was 1.5, and 870, which is 43.5. Excel was just so beautiful. And it's all about getting the formula right. And the formula comes from your understanding of mathematics to type in your thinking to get it to do your work. Okay, so we've got the percentages down, and now the question is, how, with this circle, and notice I put an arrow here, you always must put in a key or a legend. So it means if you're using different colors, for example, if I just did this and I called that onion, then you need to have a key for onion and it's red. Okay, but really the skill that I'm trying to teach you here is not what color to choose, but how do we make sure on that circle on your sheet that I'm actually going to get 2.5%? Because you can eyeball it and kind of estimate it, but then what is the accurate way of doing it? And the accurate way of doing it is, since you know in a circle, how many degrees is a full revolution? 360. So that means for onion, out of 360 degrees, I need 2.5% of that. So I need 2.5% of the 360 degrees. Anyone know how to do this? 2.5%. Hands up if you know how to do this on a calculator. Not sure? All right, let's write it in. This is how you do it on a calculator. So if you want to know what 2.5% of a number or percentage of a number, this is what you do. Write this as your notes. 2.5%, that symbol there just means divide 100. So that just means 2.5 divided by 100. Of actually means times. 360. That's what actually means. So on your calculator, you'll be typing 2.5% just means out of 100. So divide by 100. Of means times. So 2.5 divided by 100 times 360 will tell you how much degrees you need. So let's do that on a calculator. Actually, I'll do it on Excel since I already got it over here. So this is what I'm going to do. 360 degrees. Yeah, so that's my 360. And these ones, I'm going to do 15% means divide 100 times by 360. Yeah, so here we go. Here's the formula. Equals. I want C2. So 15%, but remember percent means divide by 100. So 15 divided by 100. So we go 15 divided by 100. So take that divided by 100 and then times by this number. So here we go. Shift number 8. So that star button, asterisk means times. And I select 360. Or if you want, just type in 360 yourself. Here we go. That's 54 degrees. Okay, so if I now drag this all the way down, you know you need to draw 9 degrees with a protractor. So if you had one, I'm just showing you how you would do it. Not that you actually have to do it right now. But you would actually get a protractor and you would measure in the circle. If you were to do it, you got a center line, get out your protractor, measure out 9 degrees, because they said 9 degrees, 2.5% of 360 is 9 degrees. Measure out 9 degrees as an arc, and that's your 750. Oh, so not 750. Okay, so obviously I don't have a protractor on this digital form, but if I had a protractor, what I would have done is I would have taken it here. You have that half circle. I look for 9 degrees, and I mark it. And I connect the dots. That makes it 2.5 degrees, and that's how you get accurate measure. Do you have to do it by hand? No. It's just that your exercise books says that, especially the 12s. They actually say for you to draw it by hand. Reality is that you're going to do that on Excel. So you just type it on Excel, it does it for you. But if you want to know, well, how would you do it logically? That's where the protractor comes in, because it has the degrees ready for you. That's how you would do it properly. Okay? All right, team. So I just showed you how would you find or how would you draw this accurately. This here just means make sure to draw a legend or key. Let's answer the question. So what's the scenario? You got a recipe. You want to bake beans. Here's the ingredients. Construct a pie chart, which let's say you did on Excel. You got the pie chart already. Great. Determine how many grams of dry beans are required for a serve of 250 grams of this dish. So this is where I want you to do a bit of thinking. So that's a typical Year 12 question in an exam. This is where you actually use your thinking and tell me. Because you know when you cook a actual meal, you get a full dish. But you're not going to give people that full dish. You're going to give parts of it. So what if you want to cut out a slice? 250 grams. It's kind of like when you buy a steak. You know, they say, do you want a 300 gram steak or 250 gram steak? They have to do this thinking. They have to figure out, well, how much would they need? Okay, so in this case, how much dry beans? If this is one recipe for one baked bean dish. So that's for one baked bean dish. But I only want a serving of 250 grams of this dish. Say that again. Yeah, that's it. You see, this is 15% of this dish. So 15% of this whole is dry beans. But this one whole is not what I'm giving to people. I'm giving to them 250 grams. It's a portion of it. So to make it all equal, otherwise, you know, like the flavor would be all different, I need to make sure that in here, I still have 15% dry beans. Everything still should be proportional. So this is all you need to calculate. The logic is when I ask you, how many grams of dry beans would you need if you wanted to do a 250 gram dish? Well, this is what you do. You take out your percentages and then you go to Coles and you actually figure out, maybe I don't need 300 grams of dry beans. In fact, all I need is, and this is where you do it, on your calculator, 15% is 15 divided by 100 times 250. You only need 37.5 grams. So I'm going to write the working out here. So you only need 15% for dry beans. So in this dish of 250 grams, 15% of it, you want it to be dry beans. So 15% of 250, how do you type on your calculator? It's 15 divided by 100 for 15%. Of means times. Type on your calculator, 15 divided by 100 times 250. And I got 37.5. So now you know if you go to Coles and you were going to make a dish that was only 250 grams, you don't need to buy a 300 gram amount of dry beans. You only need a pack that has just enough for about 37.5. So you might buy a 100 gram packet. You might buy a 50 gram packet. Or as you're doing the scoops of dry beans, you can kind of estimate it. Look for 40 or 50. Get me? So that's the idea of if you were doing your own recipe, if you opened up your own business and you're doing muffins or tarts, then you don't have to, or you buy in bulk, you know how much you actually need, or you buy less, you know how much expenditure you need. Because you can budget. Profit and loss. That's the whole point. Yeah, but you need to first know how much do you actually need. Otherwise, most people don't actually do that. You know what most people do? They just go out and buy. They just bake and they just look at the end. Do they make a profit or make a loss? But they don't actually do a calculation for it. That's the difference between a thriving business and a business that might be failing and they have no idea that they're losing money. Okay, so that's the idea of why you need to think for yourselves, and that's how you would answer that question there. All right, that's it for today, team. That's 5.3. It literally was just about bar charts, pie charts, and I showed you a bit about percentages and how to use that. The last question there was really just to get you to think, how do you apply it? I'm going to stop the video.